All right. So for this question, remember, we are applying reduction formula and the two fundamental identities. Okay? So we have got sine squared of 90 degrees minus theta. Okay? Now, I'm sure everybody knows that sine 90 minus theta is equal to cos theta. So this is equivalent to cos squared theta. Then tan 135, okay, 135 is in the second quadrant and tan is negative. So that would be minus, okay, let me put a plus, minus tan 45 degrees. All over cos 90 plus theta, so that's going to be minus sine theta. It's a co-ratio times minus sine of theta. Because the sine of a negative theta is equal to minus sine of a positive theta. Then we get cos squared theta minus 1, because tan 45 is 1, all over positive sine squared theta. Right? Then, now to carry on here, we may have to apply factorization in the numerator. Okay? But before I do that, I'm going to swap the position of the cos squared with the minus 1. So we have minus 1 plus cos squared theta over sine squared theta. And this will give you 1 minus cos squared theta. I hope you are following that. You're following from here to that. Right? The reason why I did that is because cos squared theta minus 1 is not really the subject or the formula for sine squared theta in the fundamental identity. In the fundamental identity, sine squared theta is equal to 1 minus cos squared theta. Okay? So because of that, that's why I had to swap the position of those two, then factor out minus 1. So you get that all over sine squared theta. Right? Fortunately, the binomial inside brackets is equal to sine squared theta. So you get minus sine squared theta over sine squared theta. And that's equal to minus 1. Okay. So hope you got that answer. Did you all get that answer? Huh? What answer you got? Okay, hopefully, if you didn't get that answer, I hope you see where you made a mistake. Okay, please be aware that your knowledge of factorization is required in trigonometry. Okay, the knowledge of factorization is required in trigonometry. All right. Right, can I move on to the next one? Where did you face a challenge in the question? Talk. Yes, Joshua. Hey, I need one person to be talking, and that's him. Okay, can you say?
I forgot the reduction formula.
All right. Okay, hopefully that will be fixed. Then number four, whenever you see an angle which is more than 90 degrees, you apply reduction formula. Okay, whatever the size of the angle. If it's more than 90, reduction. Right? So 193 is in the third quadrant, so that will be minus sine 13 degrees. Right? Then cos minus 77, that's cos 77. Okay, the cos of a negative angle is equal to the cos of the positive angle. Then minus sine squared of 13 degrees. Now tan 47 is in the third quadrant, right? But there is this square here. Now because of this square, the answer will be positive because of that. So you don't have to think whether it's tan squared, cos squared, sine squared. That will always be what? A positive. So that will be tan squared 13 degrees. Okay? Now, we have to simplify this because we have got angles there. We have to simplify it, right? Now, if you want to simplify it, my suggestion is to convert the tan to what? To sine over cos, okay? But before I do that, well, let me find the LCD. Let me find the LCD. Your knowledge of fractions is very, very important. The LCD. So the LCD is going to be tan squared 13. So what this means is this is going to become minus sine 13 degrees times cos 77 degrees. Well, I could convert this cos 77 to a co-ratio as well. Okay, I think that would make it a little bit simpler. Then I'll end up creating minus sine squared. Okay, I think let me go over that route. But please be aware that what I wanted to do, finding the LCD, it will also get me to the answer. So I kind of struggled for choice in terms of which route I should take. Okay, but I realized that since the cos 77 can be converted to sine 13, I can end up creating, or rather applying co-ratios there. Okay, but let me carry on. Right? Let me carry on. Maybe I can do that as method 2. So I'm going to have here tan squared 13 degrees minus, here I'm going to end up having sine squared 13 degrees. This is all over tan squared 13 degrees. Okay? Now, this tan squared 13 degrees, I can write as sine squared over cos squared. Right? Please be aware that I might be taking a long route, but it's fine because I'd already started it. So I can't stop. So this will be minus sine 13 degrees times, well, okay, let me write it cos 77 times sine squared 13 degrees divided by cos squared 13 degrees minus sine squared 13 degrees. This is all over. Well, let me just put this in brackets. Then I'm going to divide it. Okay, this will be divided by. Now, this denominator, I'm going to convert it to sine squared of 13 degrees divided by cos squared of 13 degrees. Please be aware that this method might be a little bit longer. I'll do it using a much shorter way. I realize I can do it in a shorter way. All right. Now it's very interesting because this cos here, it can disappear. This cos here, it can disappear. So let's make it disappear. So, no, it can't. Right, it can't. I'm going to convert this to sine. So on the next page, can I carry on? Huh? Yeah, it's a little bit long because of the way that I decided to approach it. So we'll end up getting minus sine, and that should be, this one here is going to become cos 13, so we end up having minus sine 13, that will be a cube now, okay? So this will be minus sine cubed, okay, but I'm not supposed to write that, but I need to show that I use co-ratios. So that will be cos, sorry, sine 13, right, times sine squared 13 degrees over cos squared 13 minus sine squared 13. This is, well, I'm going to put cos squared 13 over sine squared 13 degrees. Yes?
Why does the cos change to sine?
Because I use co-ratios. Co-ratios is this one. So it will be sine theta is equal to cos 90 degrees minus theta. Or you can say cos theta is equal to sine 90% minus theta. Okay, you can use correlations to convert sine to cos and vice versa. Well, okay, I hope you saw how I end up converting that division, this division here, to multiplication.
So I will divide it cos 77 by what?
I use correlations to convert cos 77 to sine.
How?
Correlations. I use correlations. Okay. All right. Okay. Now it gets a little bit interesting, but I can see that I'm almost there, and I'm smiling a little bit. All right. So when I multiply 1, 2, 3, they will give me minus sine 4 13 degrees divided by cos squared 13 degrees. Alright? Minus sine squared 13 degrees. Now this is, all this is inside brackets times cos squared of 13 degrees over sine squared of 13. Now, look here. I hope you are all aware that inside the brackets we have a binomial, isn't it? Right? Multiplying the monomial. So when I distribute, okay, that monomial there. Okay, when I say monomial, I'm referring to this fraction. If I distribute it, okay, you are gonna get this. If I distribute it, these two, okay, sine squared 13, they are going to cancel with 2 from there. Okay? Because when I distribute, that's what's going to happen. And then this cos squared 13 is going to cancel out with that. Alright? Are you following that? So what that means is I'm going to be left with minus sine squared 13 degrees. Then, when I distribute with this one here, and I multiply with that, I'm going to end up getting this cos 13, sorry, sine squared 13 cancels with that, right? And then I'll end up having minus cos squared 13 degrees. All right? Now, I'm almost there. Okay, I'm smiling already. I'm smiling. Then I'll factor out minus 1. If I factor out minus 1, I'll get sine squared 13 degrees plus cos squared 13 degrees. And this will give me minus 1. Okay, when you multiply this fraction by this fraction here, right, when you multiply it, because there is multiplication there, this cos squared 13 will end up cancelling with that, because it will be part of the numerator, and this will be the denominator. Then, 2 of these 4 will be cancelled out by those 2. Are you following? Yeah, please, if you are not sober and you came to school today and you are not in a very good state of mind, you won't get what I'm doing here. Huh? Yes. Ask. She doesn't understand which part. You allow her to speak. You don't understand which part.
I understand the cos.
Yes.
I understand the cos minus the cos.
Okay, when you say what do you mean cos minus the cos?
I mean the cos 13 and then the difference.
Okay, look here. You have got 4 sine 13. 4 of them. And then they are divided by 2 sine 13. How many sine 13 will be there? 2. That's why I've got sine squared 13.
So and then
What about the minus? This minus here. This minus here is the minus which is already there.
yes,
Sir, what happened to it?
like what happens to the sine squared 13?
Which one?
That one.
Are you talking about this one here?
Yes.
It multiplies with this fraction as well. Remember, this is a binomial.
Yeah.
This is a binomial. It's multiplying a monomial. So this multiplies that first. Then this multiplies this sine squared 30. Now check this. If you multiply sine squared 30, can you pay attention? Can you stop talking? This sine squared 30 multiplied by this fraction. Numerator times, sorry, this is like a whole number times numerator divided by sine squared 30. But these two are the same. And one will be a numerator, the other will be what? A denominator. So they will what? They will cancel out. Eventually, you'll be left with this.
So when did you get the constant?
It's times
Alright. I think, okay, look here. What I'm going to do, let me squeeze that step, which probably I didn't write down. Because I thought you'd be following. Alright, so this will be minus sine squared, sorry, sine 4, 13 degrees times cos squared 13 degrees divided by, we multiply that and that, we get cos squared 13 degrees times sine squared 13 degrees minus, okay, minus this times that, we get sine squared 13 degrees times cos squared 13 degrees all over sine squared 13 degrees. Now I think probably it's clearer to you. Okay. So what's going to happen? This cos squared 13 cancels with that cos squared 13. Then two of these four, they cancel out with the sine squared 13. So you end up having that sine squared 13. Then here, these two will cancel out. You'll be left with that cos squared 13. Okay, let's do it using method 2, which is probably method 2. I'm going to make it a little bit shorter. It will be at least 5 months. All right. Are you following, all of you? Huh? Natalia, are you following?
I don't understand, honestly, but I'll work with my tutor. Because I feel like everyone else is getting it, I need to just work on it myself.
I'm going to do it using method 2. Right. Method 2, okay, let me bring the question. Okay. Method 2, can I have your attention, please? Method 2, please write this in your book. Can you write that as method 2? Method 2, this is the same as minus 13 degrees. That's cos 13 degrees. Sorry, cos 77 rather. Cos 77. Right, minus sine squared 13, that will be tan squared of 13 degrees. Are you following there?
Yes.
Right. Now, method 2 is going to be a little bit shorter. So we'll convert that cos 77 to sine 13. And I'm sure after I've used method 2, you should be able to understand it if you didn't understand the first one. So this is minus 13 times sine 13 degrees. I've used co-ratios. And I expect everyone to know that cos 77 is the same as sine what? Sine 13. Am I right there? Right? Then, what? Co-ratios. Co-ratios. First and second lesson of your grade 11 trick. Right? So this will be sine squared of 13 degrees. Then I'm going to say divided. See this tan squared 13. I'll remove the division line and put what? The division sign. Then I'll convert it to sine squared 13 degrees over cos squared 13. Are you following there? Huh? Okay, then these two will give me minus sine squared 13 degrees. Then here I'll say minus sine squared of 13 degrees times cos squared of 13 degrees divided by sine squared of 13 degrees. Are you following? Please be aware that your knowledge of fractions is very important. Fractions. Okay? Then I'm already smiling. So minus sine squared 13 degrees. Now, do you see that because of multiplication, this sine squared is 13 and that sine squared 13, they are going to cancel out. Do you see that? Right? So, we'll end up getting minus cos squared 13 degrees. And then, from here now, I have to create the fundamental identity. Sine squared theta plus cos squared theta equal to 1. So how can I do that? Factor out minus 1. So this will be minus sine squared 13 degrees plus cos squared 13 degrees. And the answer will be 2. Okay, surely you should be able to understand method 2. Right? If you missed out on method 1, which was a little bit longer, then you should be able to understand this. Right, any question? Any question? Right, if you don't have a question, then let me give you a class. Alright, we have, so first thing, we have got sine 510, so you subtract 360 from it. Right? If you subtract 360 from 510, you will get 150. Right? Then, so that will be the same as 2 sine 30 degrees. Okay, because sine 150 is the same as sine 30 degrees. Are you following what I'm saying? Okay, alright, let's go back to the basics. Let's go to the basics. So this is 2 sine 150. Am I right?
Yes.
Because there is no mark allocated for writing 510 minus 360. There is no mark allocated for that. Do you understand that? So even if you write it down or you don't write it down, no mark is allocated. Okay? Minus, okay, that would be minus cos 20 degrees. 340 is in the fourth quadrant. 340 degrees is in the fourth quadrant. So if you subtract 340 from 360, you get 20 degrees. So you have cos 20. Then times cos minus 20, that will give you cos 20 degrees. The cosine of a negative angle is equivalent to the cosine of the positive of that angle. Okay? Then, in the denominator, we have cos 110. Now, to get 110, which angle do you subtract from 180?
70.
It's 70. Right? But, listen, but there is a square here. So your answer will be a positive cos squared 70 degrees. Sine 150. 150 is in the second quadrant and sine is positive. Okay? So you end up getting 2 sine 30 degrees minus cos squared 20 degrees all over cos squared 70 degrees. Okay? Now, sine 30 is a special angle. Okay? Can you all look on the board? Sine 30 is a special angle, which is a half. So here we'll get 2 times a half minus cos squared 20 degrees all over cosine squared 70 degrees. Right? 2 times a half will give us what? 1. 1 minus cos squared 20 degrees divided by cos squared 70 degrees. You end up getting sine squared 20 degrees. If you use the fundamental identity. Are you following that? Am I talking to myself or what? Okay, if there's any issue, can someone talk? Yes.
So why is it 1/2?
Sine 30, it's a special angle.
Special angle is 1/√2, isn't it?
We're talking about sine 30. Okay? What is the ratio for sine 30? You can use your calculator to check if you want. Sine 30 is a half. Okay? Sine 30 is a half. So this sine 30, it will give you a half. What is a half times 2? 1. Right? Then you get 1 minus cos squared 20 degrees. Right? Then you apply the fundamental identity. Convert cos to what? To sine. You get sine squared 20 degrees. But then, in the denominator we have cos 70, in the numerator sine 20. They are co-ratios. So I can convert the cos 70 to sine 20 or convert the sine 20 to cos 70. In the end here, the answer is going to be a 1. Okay? But before I write the answer is a 1, you need to convert the, alright, it's your choice, right? Sine 20 to cos 70, but you have to show the application of co-ratios. Don't just write 1. You lose the mark for applying co-ratios. So this will be, I think there I like cos 70, so I would say cos squared 70 degrees divided by cos squared 70 degrees. Alright, someone might say, how is he getting that? Look, if sine 20 is equal to cos 70 degrees, it means that sine 20 degrees squared will be equal to cos 70 degrees squared.
So who said sine 20 was equal to?
You want us to go back now? How many times did I say co-ratios? Go back to the second lesson. The second lesson we had. First lesson, I discussed 12 reduction. Second lesson, I did 4 co-ratios and 3 negative angles. It's your responsibility to memorize those reductions. Hey, listen, memorize. Reduction formula. Memorize. Okay? Once we get to that, this is going to become a 1.